So my name is Robert Taylor. I'm mostly associated with the SHC, and I just recently led a task which is almost finished called Task 69 Solar Hot Water for 2030. I don't know if any of you have heard of that, but I'll give a short presentation on that here in a bit. And now that that task is ending, over in the SHC, we're starting a collaboration group on basically the same topic. So maybe I'll turn it over now to Zhao to talk about what these collaboration groups are in the SHC.
Okay, thank you, Robert. My name is João Cardoso. I'm from the Solar Heating and Cooling Executive Committee, and I would like to briefly address very briefly what are these things about collaboration groups, because collaboration groups, they are a new framework within the solar heating and cooling TCP. They were officially created last year, and they started being implemented throughout 2026. And collaboration groups, in a very short sentence, they are a framework for knowledge sharing, discussion of new ideas and activities with minimal bureaucracy. So trying to reduce as much as possible the bureaucracy that was implicit in tasks, for example. So what are the purpose and objectives of the collaboration groups? We want them to create and maintain interest in new or existing areas of research. So in the case of solar hot water, it's an existing area of research with the aim of increasing the participation and the support to the solar heating and cooling TCP mission, and with the aim of starting new tasks. So basically, we aim to create these collaboration groups structures in order to maintain a basic level of activity and expert engagement in strategic areas for the solar heating and cooling TCP that are of interest even after the end of a task. So we aim to facilitate the collaboration. So we want these collaboration groups to allow for cooperation and freely exchange of ideas. We want them to encourage discussion, providing this structure as a platform for open and constructive dialogue. And we want them to be a focus for knowledge sharing so that experts can share their experience, their expertise, their knowledge in a given topic, a specific topic, not very specific, not so detailed as a task, but a little bit more broader, so in a more strategic and general sense. We also want these groups to be a repository of knowledge so that the ideas that have been developed in previous tasks that have run up to its end are not lost and forgotten. And we want them really to support our mission, namely the development of high quality information and to provide capacity building through collaborative work. So this is basically, if we would have to summarize it in a single sentence, we aim these collaboration groups to be able to create synergies, to activate and develop expert networks throughout or continuously, so even when a task is not running, and we want them to foster the development of new joint activities. So ideally, this would be leading to new tasks. So far, we have started these creating the 5 collaboration groups, so in 5 specific areas. One of them dealing with solar neighborhoods. So this one is going to focus on advancing methods and practices for optimal neighborhood scale solar utilization in diverse urban and rural settings. We have also another one that is dealing with solar cooling. So we aim these to be focusing on industrial and commercial applications for solar cooling with a specific focus in the cooperation with the Global South. We have a third one dealing with solar heat for industrial processes. Here we want this collaboration group to serve as a platform to bring together experts in the field of solar heat for industrial processes, developing the network, new ideas, and to really start this some activity in this area, new tasks. And another one dealing with solar district heating and cooling. So this should be dealing with stimulate the development of new collaborative projects in this area of the district heating and cooling, considering not only the solar thermal technologies, but also the integration with other systems that are present in the district heating and cooling networks. And last but not the least, we have the Solar Hot Water Collaboration Group. And for this one, I think that we want to discuss with you what we want to do. And I won't be talking about it because Rob now is going to do so. So I'm giving the floor to him. Just saying one other thing, that if you are interested in any of these topics, or if you want just to know a bit more about what it is, just go and check in our website the collaboration group, so you can follow this link. Okay, thank you.
All right, thank you very much for that introduction. So you can see that's new for the SHC to have these kind of ongoing things, but I guess PVPS, you always have ongoing tasks in areas. So maybe not new for you guys, but there is some areas in there. All of those just say solar cooling, solar neighborhoods, which means that PV could be involved in that as well. So I'm sure there'll be people from PVPS that would like to join those things. All right, so what I wanted to do is, I think there's quite a few familiar names in the participants, attendees, but maybe not all of you know about Task 69. So I just wanted to say a few words about what we've been doing in Task 69 for those that are new. Hopefully it won't take too long, but I just have a few slides that I'll share on our task, which is now coming to an end. I
Meanwhile, you
don't
are
use Zoom
preparing.
very much.
Yeah, meanwhile you are preparing, I wanted to add that these collaboration groups are mirroring exactly what at the moment is trendy and asked by IEA to enhance more and more, let's say, mix and collaboration between TCPs. So that's really online, and that's great at our level. The floor is yours.
Yeah, no,
Rob.
yeah, thank you. And also, Daniel and I have been coordinating this workshop, and yeah, he put his hand up at the very first to be involved in this collaboration group. So that's already a good link between SHC and PVPS. So anyway, so yeah, so I was one of the task managers. I have a task manager from China named Professor He Tao, who's at the China Academy of Building Research, and we've run this task for the last 3.5 years, I guess. And basically, the focus for the task from SHC was on thermosiphoned hot water heaters. So that's thermal-driven hot water heaters, and then PV hot water heaters, which are emerging. Basically, anywhere where you've got a little bit of excess PV, either on the grid or on a house, you could actually use that and suck up that excess PV into a hot water heater, right? That can take many forms. But I guess those two technologies are probably, either past dominant technology or probably going to be the future dominant technology for how we can sustainably heat water. And both of those technologies actually, I was surprised while doing this task, they all have opportunities for new products, new components, and there's a lot of opportunity inside there. So, you think of thermosiphons as an old technology that have been around for a long time, but there's ways to make it smarter, ways to make it more durable and reliable. And so there's quite a bit of kind of innovation going on from companies out there. So, of course, the significance of hot water is that it's even in pretty economically developed countries like Australia, it's still a pretty good chunk of the household load in a residential building. And in some locations, like we visited Namibia last year, it can be up to 50% of the household energy demand goes to hot water. And actually, surprisingly, in Namibia, where these pictures are from my visit there, that the energy costs are almost as high as Australia. So putting 50% of that cost in a kind of whenever there's not that much income for some of the people there, it's quite a big cost. There was also an IEA report, it's a few years old now, but that said that we need to get to 400 million solar hot water systems worldwide by 2030 if we want to reduce, get to these targets, emissions targets. And many countries around the world have climate or renewable energy targets now. Not every country is achieving those targets, but solar hot water is something that you shouldn't forget about as a way to get towards those targets because it's a big energy demand and it's potential that there's a lot of interesting things that we can do with solar hot water systems to help meet those targets. But it doesn't look the same everywhere, right? So different countries, different climates, different income levels, different skills sets in the economy, and different regulations might dictate different technologies are the winners. From this task, we did quite a bit of work and tried to figure out, what technologies are installed now, what technologies might go in the future, and how to maybe make those technologies better. So we had a report on like failure modes and effects analysis of some solar thermal systems. We collected some case studies from industry on emerging technologies and things that will make technologies more sustainable, more reliable, and also bring them into the modern age with IoT things and smart controllers and apps and stuff that you can get. And we also had, again, another thing from the Namibia visit, we also did there's a comparative study where they have side-by-side PV hot water heating and a couple different thermal technologies there side by side. So we were looking at those comparisons. We did some surveys in our task, and we found what are manufacturers looking at and looking at developing. A lot of manufacturers are looking at things that, maybe seem like they've been well developed, but they still need innovation. So mounting systems. So like in the case of in Asia, mounting these technologies on the balconies of buildings, even PV hot water heating technologies out on the balcony and making that safe. Just ways to incorporate solar collectors in the building facade is an interesting one. And of course, like I said, the smart systems and monitoring systems. There's some materials innovations using plastics to kind of lower costs, trying to find materials like aluminum and new working fluids, which won't be suffering from corrosion or maybe could go to higher temperature in places like Africa without having issues. And of course, these kind of, little apps and monitoring systems, because previously, some of this hot water technology had no idea how much solar energy you were generating into your system. So in terms of what we've done in the task, there's a link here, maybe we can share these slides, but if you go look up our Task 69 publications page, eventually all the things will be published there, all the reports. So there's about 10 reports, and then there's some links here for several journal papers that were also produced for the task. And actually, most of the journal papers ended up being around PV hot water heater systems and how to get the most out of those, basically. And so there's a lot of interesting academic stuff in there. A lot of it came from my colleague here at UNSW, Baran, and some people in Australia for some of those journal papers. And anyway, it's very interesting to me because it's quite cross-cutting across different operating environments and different markets. So, in Australia, for example, one challenge in our market is that a lot of the PV systems are being curtailed. So last year we had something like 10 gigawatt hours of PV electricity got curtailed, which turns out to be the exact same 10 gigawatt hours that we need for hot water heating. So it's just a matter of trying to like match up that thing in this operating environment. I think Australia is kind of living in the future for how much residential PV we have relative to the rest of the world. And also in places like these pictures here in Africa, the solar thermal systems are still going to be dominant for a while because that's a pretty robust technology that can go in those locations, but they do need a few innovations and some ways to make those more reliable. So different challenges, different operating environments. So that's why I think it's good to continue after Task 69 and keep working on that. Okay, now I just need to stop sharing my screen. Um, yeah, so that's my quick overview. Hopefully it didn't take too long.
No, that's great. There's just a couple of small scope clarifying questions in the chat that maybe I should address to you before you hand on to Ricardo. So one was just, it's kind of about Task 69, but also about the discussion today, just clarifying what temperature of water heating you're talking about. And Daniel suggested between 40 and 60 degrees.
Yes. Okay. So temperature. So yeah, hot water systems, they can't be too hot, right? Because you don't want them to boil. That's one thing. And you definitely want them to be hot enough to do your domestic hot water. So yeah, 40 to 60 is good enough. There's also in Australia where we have storage tanks, Legionella can be an issue, right? The bacteria that can grow. And so you got to get at least some kind of heating cycle that kills off that Legionella. So that's above 60 degrees usually at some points in the time, but 60 is too hot. 50 is scalding temperature, right? So you have to have some way to make sure you don't make the water too hot for the customer. In other places where the water just comes in and goes out and it's heated on demand or something, maybe you don't have to heat it up to 60 ever because you don't need that high of temperature. I think.
And the other question was whether the task considered PVT. And,
PVT.
but Joao gave the link to the separate SHC task about that.
So we at the very beginning we took the decision to just focus on thermosiphons and PV and not PVT because otherwise it would get too large of scope. And also the SHC has had and currently has a PVT task. I don't know what E2P it means. E2P. What's that, Daniel Monnier?
No, that's a question from Simon, French CSTB, and E2P is not clear for me. Energy to power.
Energy to power.
Okay.
You mean energy to power. So do you mean converting the thermal energy back into electricity?
Of course.
Oh, using electricity for thermal. Yeah. So PV hot water is, of course, using electricity to make thermal energy, right? Because you're going to use electricity. There's still a few ways you can do it. The simplest way is what we call PV to heat. PV to heat, you don't have any complicated electronics or inverters or anything. You just use DC from the PV module and run it. You need a little bit of maximum power point tracking in there, but then run it into a resistive heater. And that's pretty dead easy. And you avoid batteries and anything expensive. And it's just dedicating the PV module to the hot water heating, doesn't do anything else. There's another one where you can have it's going to probably be pretty common in Australia where you have PV diverter, where that means if your house has excess PV and you normally would be exporting it back onto the grid, instead you divert it to your hot water heater or maybe some space heating applications. And then there's another one where you can divert it to heat pumps. And then heat pumps give you the COP of 2 or 3 or whatever, and that's a pretty good, but it's a little more expensive. So there's lots of bells and whistles you can add along the way.
Okay.
All right. So I think Ricardo is next. I don't know if you had some slides you wanted to share from the PVPS side.
Perfect.
You're still muted, Ricardo.
Yeah.
But you did get the full screen, unlike me, the first time.
Yeah. Congrats. Okay, Ricardo, yeah, the floor is yours.
Thank you. It's nice to be here on a personal note because I started working on solar thermal for domestic water applications some amazingly 40 years ago, not 14, 40. And by that time, it was pretty stupid to think about photovoltaics for heating water. The efficiency was around 10% and the costs were very high, and so it could not be compared with solar thermal. Well, the things have changed and prices have gone down and efficiency has gone up, and at some point it makes sense to use photovoltaics. I will show you a work that it has around 2 years of comparing various solutions for domestic hot water, not just solar, but I think it will be interesting to see the various technologies, how they compare as a starting point for this collaboration between these two TCPs. So that's it. I came from Directorate General for Energy and Geology of Portugal, and I am also the ExCo for Portugal in the PVPS. But I am sharing here my expertise in another areas. So the context of this work, as I said, it was not PVPS, not CHC TCPs, but rather something that we in Europe must do in the context of public policies for adjusting the regulations of the building regulations, especially the new buildings. We must keep the requirements aligned with the cost optimal criteria. So for that purpose, we have some methodologies and ways to do it. And in that context, we are required to make a study of comparing various solutions and find the optimal ones. But this is from a cost optimal perspective, but here I'm going to expand to other criteria as we shall see. So the research questions of this work was, first of all, what is the cost optimal technological solutions for domestic hot water? And then, as I said, trying to other criteria. The renewable share is very important nowadays. The Portuguese new regulation or rather national target, I mean, will require more than 75% renewable share of energy in new buildings. But there is also the energy ranking of buildings where the local renewable share, meaning the share of renewables that can be used from the environment at the site of the building, and there are other issues that are also of practical importance. In the original work, there were some other research questions regarding geographical and climate variability, but I will not go into that. But keep in mind that this is for the Portuguese context. I think it will apply to most sunny countries. In the more cloudy climates, it may be somewhat different. These were the solutions examined. So solar thermal with electrical backup, not with gas backup. We immediately detected that with a gas backup, the comparison was not good for solar thermal. So we have only used electrical backup. So electric boiler, a direct link with the grid electricity, with also PV and natural gas boiler, biomass boiler, and heat pumps, two versions, one for fed with the grid electricity and another one also with the self-consumption of PV. So there are no solutions with storage because, of course, in this case, we already have a tank of hot water which is the storage, so we don't examine things with batteries and stuff. We already have the storage. I will not bother you too much with the methodology and the assumption of the work. Just to say that we have followed the guidelines for the cost optimal calculations issued by the European Commission, and this includes evaluating the performance of the systems for around 30 years, and this is more than the lifetime of most systems. So we have this substitutement of parts of the whole system sometimes. Maintenance, etc., is all included, and also to point that in the case of our country, there is a large effort for decarbonizing the grid electricity. So it kind of contains a lot of implicit renewable energy. So it's not yet comparable with PV mounted on the building, but we'll go to that in some decades. By 2045 or so, will converge with almost 100% renewable in the grid. So it must be seen as an indirect way of using PV, but in the grid electricity instead of in the building. And also decarbonization of gas-based solutions, but then with biomethane and hydrogen, but that only goes to 20% decarbonization. But anyway, this was also taken into account. So I think we did not left anything obvious outside of the work. So this is the, let's say, the main results. We regarding costs, we obtained this result. So solar PV and biomass. When I say solar PV, you must think of PV directly connected to the boiler, to the electrical boiler. That's what I mean by solar PV. So we have the list costs are for solar PV and biomass. Solar thermal is not too far. And there are costs, much larger costs for heat pumps. But as I will remark at the end, again, these heat pumps are multi-use, so they do space heating as well as domestic hot water. So that's why the costs are so wide. And the electric boiler, the costs are high because of the costs of grid electricity being much higher than the costs of solar PV installed in the building, on the building, I mean. So we done some sensitivity analysis on these results, and they have these bands, and they should be within these bands, the results, even when we change the price of the systems, efficiencies, cost of electricity, etc. So the ranking is pretty solid. It doesn't change very much with these assumptions on costs in particular. So from the point of view of just costs, I already said what. In this case, we have added the natural gas boiler. The costs are also high. on the high end of the scale. So, but again, this is the basic result regarding costs. Now, there are other points of view, and I work in a director general connected to the Ministry of Energy and Environment. So my point of view is sometimes different from this cost-only point of view. And we have the point of view of the building regulations. And for that, it's important the local share of renewables. And in that case, you get, again, solar PV at the top, 100%, then biomass and solar thermal. Now, this 80% solar thermal could be gone up to 100% if you use solar PV also as a backup to the solar thermal system. But the thing is that both solars come up at this, produce energy at the same time. So in principle, these backups are for cloudy days and nights and etc. when neither solar PV nor solar thermal is available. So that's why it's not on top 100% as solar PV, this option of solar thermal. So this is the local share of energy, of renewable energy. And then there is, so that's important for classifying the buildings. And then there is the National Energy Policy's point of view, for which you want to maximize the renewable energy used by the building in the general context. And well, from that point of view, all the systems except for the natural gas case are above 90%. So even the electric boiler fed by electricity off the grid, in our special case in Portugal, assessed over 30 years, not right now, but over these 30 years would be close to 90%. So all these solutions will be, let's say, desirable from the point of view of the broader context of national energy policies. So other criteria. Of course, all this can change if we think about other things. So if you have just an electric boiler, you don't have other equipment. You can save space indoor and you don't have things outside the building, etc. If you have a natural gas boiler also, but then you must have ventilation and requirements for air quality, etc. If you have biomass, again, you have the problems of storage space for biomass. Indeed, you don't have to use area on the rooftop, but you have air quality issues, especially if you use biomass inside a dense urban area. It's not desirable. Heat pumps, well, they have this advantage of attending to space heating also, but you have an external device. The heat pump itself, it's outside the building, and that's an aesthetical problem. Besides the price, I'm not talking prices right now. And when you, with the heat pump, you still have the problems of external devices, but it's best in terms of primary energy. And as the heat pump is as a COP of 2 or 3, as Rob mentioned, you also do not need to use large area on the roof, which is the advantage of solar thermal, a big advantage of solar thermal over solar PV, which is it requires smaller areas because it has more efficiency. But as a problem regarding or in contrast with solar PV, of the collectors must be tilted, and this is a problem of aesthetics. And but it has a large advantage that it's not usually mentioned. It is in the context of reshoring the industry that has gone to China, basically, not just to China, but also to other countries, India, Indonesia, etc. It's easier because it requires only, let's say, glass, steel, some insulation, aluminum, things that are more available for the and easier to handle for the European industry, which is, I'm sorry to say, my concern, than in case of solar PV, which is, as you know, dominated by Chinese products. And finally, regarding solar PV, we have this problem of larger roof area, but we have also this advantage of flexible use of energy, less plumbing needed, etc. So you have a number of advantages in PV. But all the solutions have some kind of problem, and it will depend on the actual context where we apply the technology to find the best thing. So, for instance, just to finish, if I would say that if I am in Portugal and have a new building with the apartments, say 6 stories or 4 stories of apartments, you don't have much room on the top to install PV. Regarding you, if you have 20 fractions, 20 apartments or so, you don't have much space on the roof to share. So I would probably go for a solar thermal. But if I am in a detached house, a residence isolated from other buildings, I am not so concerned about the space on the roof, and I would probably, in this case, use a solar PV-based solution. So it depends on the actual context, what kind of solar hot water solution is best. Thank you.
Thank you very much, Ricardo. And again, I would direct your attention, well, to one of the questions was from me, but there's a couple of questions in the chat.
Yes.
Following up on the details.
If I may, Emily, as time is running, it's already 11:15. We should maybe go quite fast on the questions and go to the Miro exercise if we want to have time. But then, yeah, there are rapid questions, yeah.
Ricardo, did you want to give comment on whether the primary energy included the embedded energy or just operational, and whether service and maintenance were integrated in their approach?
Yes, service and maintenance were included, and that's more favorable for PV, of course. But regarding the embedded energy, well, you see, I came from the public policy side, and the emissions, let's say embedded, not the right word, but embedded in the actual construction of the systems are in the manufacturing industry. So they're assigned elsewhere. So we don't use that. We don't use a life cycle analysis that includes the embedded energy, because they are already accounted for in another sector of the economy.
Perfect.
But I could use that, but it would not change the results. It would Yeah, okay. Photovoltaics is expenses in terms of embedded emissions, production of the siliconates and wafers, etc. But so is steel and glass in the case of solar thermal. In the end, it was not alter much the results. That's my feeling, having gone through various lots of computations. That's just a feeling. I cannot give you detailed data.
Thank you so much for the presentation. And Rob, I think you'll jump back in now to explain the Miro board.
Yeah. So I think I posted in the chat. Hopefully everyone can see the link there. You have to do a little bit of work to get Miro, to get into the Miro. You just have to put in your email address or something like that. But I see a few people are coming in now, so it's obviously working. There's one more question in the chat on wall-mounted PV for water heating. I don't know, Ricardo, if you want to say anything about that.
Come again, Rob.
Yep.
What is the question?
The question I think is about it's like building integrated PV for water heating, if you did any of that costing or
I'm sorry, the dog is barking a bit, so I can wall-mounted PV for water heating. No, I don't have any views about that. I think that in that case, PV can be used for anything, not not especially for water heating, but as a general application.
Yeah, Ricardo, I can confirm. I can confirm this is really not something which is the maximum vertical applications are much more for heating. But water heating, I think, is really a niche, extreme niche. So yeah, I confirm, Ricardo, your thoughts.
Yeah.
Okay. Well, maybe we can switch over to our Miro board now. So in the Miro board, because I'm an engineer and I set this up, I made kind of a grid there. Hopefully we can kind of go one by one through the rows of the grid, right? That was kind of my plan. So the first, and everyone can contribute in there. Hopefully everyone's getting in. I think there's at least 7 people in there now. But if you haven't gotten in, try to get into the Miro board. And basically, the top row of the grid is asking about what technologies are dominant and what are the trends in each of the potential regions. So you can fill in something if you have some comment on the global ones, or you can go to your region where you're representing. So those of us from Australia, we would fill in little sticky notes from Oceania. So hopefully you can see my thing. But if you go down to sticky note, you can pick a color that you like and put in a little sticky note, and you can say, solar thermal evacuated tubes or something, and put that in there. And yeah, if we could just go along that top row now and add in some of our thoughts from your region or from the global one, if you want to make some comment on that, or if you know something about the other regions, you can write that in. It'd be good if people put in at least their name or their initials in there so that we can keep track of who did what. Anyway, that's good. So what I'll do next is I'll try to take all these sticky notes from the Miro board and some of the comments from the chat, hopefully, and I'll put it down at the bottom row there. I don't know if anybody saw it, that says key takeaways, and I'll try to pull that all together over the next few days. And again, the Miro board can stay open. You can keep adding more things in there, and then we can send it around. I guess this participant list is the start of a mailing group for our collaboration group, and yeah, if everyone wants to if anyone wants to take themselves off, let me know. But otherwise, I'll probably we'll try to email everybody the key takeaways and some of the things from the meeting. And then we had sort of thought we could have quarterly meetings or something like that for this group. So hopefully this initial meeting will help us to figure out some areas that we want to really focus on. And maybe the next meeting we could look at a couple of these things in detail. So for example, this policy thing, if that's of interest, or maybe Samson and people from Africa that are interested in the industrial applications, maybe we can get some fact finding between now and then share it with the group to inform everyone and have some knowledge exchange at the next meeting. So I'm thinking this is what, Q2 or something, but maybe we can have another couple meetings before the end of the year, each quarter would be my goal. All right, so I think that's all that we had on our agenda. Oh, sorry, one more thing there, Zhao. Is anyone attending Eurosun? Some people in Europe. There'll be a session for the collaboration groups at the Eurosun conference if you're attending that. I guess not sure what the timing is, if it's in the schedule yet or not. Do you know, Zhao?
I believe it's not in the schedule yet, but there will be a session dedicated to the collaboration groups. So if you are in the conference and you are interested in checking what is the status, what we have been done, we will also be for sure talking about this one. Just attend to this dedicated workshop that we will be having there. Yeah.
Okay. So with that,
I think you can expect at least 2 emails from us this week or within the next week, because I'll send around tomorrow just the slides, the link to the Miro board again, so the people who maybe had to leave or didn't make it today could even add their comments as well. And then there'll be also, this was recorded. And then, as Rob said, he'll send around another email in a few days or within the next week with the kind of final outcomes or summary of the Miro board, which would be great.
Yep. And if anyone wants to present at the next quarterly meeting, let me know if you have some idea that you think you could do a little bit of fact finding on a topic, and we could do 2 more presentations probably or something like that next time. All right, so I guess we're 3 minutes over our allotted time there, but thanks everyone. Thanks for all the inputs into the Miro board. I can see that's a lot of new information that I didn't have before this meeting, so that was great. It's nice to have so many people from different regions getting different perspectives in there. So I think with that, we can probably close it off. Emily?
Yes, thanks to everyone for coming, and thanks to Rob and Ricardo and Joel for the presentations at the start. We'll see you all next time.